the production databases. Okay. So the central process which governs the Optim Data Privacy Solution is the Optim Convert process. So the Optim Convert process is a process which is responsible for masking, transforming, converting, and privatizing data for testing and security purpose. We can execute this convert process automatically after the extract process, or it can also be done using a standalone convert execution. I can also execute a convert process as part of the insert, update, and load process when I am once I have finished the extract from the production data. Before I load to the target environments, I can initiate the Optim Convert. It also has got features wherein I can produce comma-separated values. It's not always required that I am loading the target environment directly. I can even create comma-separated values file, which can be studied by non-technical people. I mean, there might be certain individuals where, for example, business executives who not really are interested to log into the database and see how data has been modified or changed. So they are more comfortable working on Excel files. So I can produce a sample output from the privatized data and store them in Excel sheets and share that with the executive team. The Optim Convert process consistently transforms production data for use in QA and the testing environments while maintaining referential integrity and protecting the original data from use for which it was not intended. Okay. So it's very essential that if when I'm modifying the data from the production system in the extracted file or the extracted data, I have to ensure that the referential integrity that was existing in the production system is also maintained in the privatized data. Okay? Otherwise, the application logic will fail. So convert processing by default comes with a TDM implementation. So Optim Test Data Management Solution is a separate licensed product, and Optim Data Privacy Solution is a separately licensed product. But certain features of data privacy comes by default as part of a TDM solution. And when additional licenses are purchased for data privacy, you will have additional convert processing features such as keyed lookups, random lookups, hash lookups, aging, currency, and it has got a number of prepackaged lookup tables. So TDM has got certain elementary data privacy features, and if you want more robust and more enterprise level data privacy solution, then you will have to get additional licenses for Optim Data Privacy. Convert components. As part of the convert request, the access definition or the code which basically governs how the convert will happen is stored in what is called as a table map and a column map. Table map specifies the target and the source tables. Column map specifies the source and the target columns. And you have an option of privatizing only specific columns of a table. I can also use built-in functions for doing this data privacy. And I can also write user exit. User exits are custom code which are written by programmers wherein we want to implement something which is not readily available in Optim. Right? So if you have a custom logic or if you have a specific enterprise requirement which is very unique to your environment, I can write a user exit program using C++ or Java, and I can invoke that procedure using the user exit feature. We would see in this slide how to perform a convert. Okay, so the convert screen, you will have to first create a convert request, wherein you will define how the convert request will basically work. You will create a table map, wherein you map the source and the target tables. You define the column maps, wherein I select particular columns which I need for data privacy. And I edit the source column using a variety of methods, and I can specify the data privacy routines in the source columns, source column map. So this is the convert request screen. We specify the source file from where, which becomes the source. The source file contains the data which has to be privatized, and the destination file contains the data which will be stored after the privatization. Table map options, you can specify it as a local table map or a named table map. A local table map is something which is very specific to this convert request, whereas a named table map will make it more generic and will make it available to other requests in the Optim environment. I have an option of creating a comma-separated file by selecting that option in the convert request editor. Column map attributes. The column maps basically contain the core of the data privacy solution. Here is where the data privacy actually happens. And all these various Optim objects, whether it's a convert request or an archive request or a table map or a column map, all these are stored in an Optim directory. An Optim directory is a repository. It's like a system catalog wherein it stores information about the Optim environment and will ensure that this information is available to other users based upon how the security credentials are set up. So you'll see how a column map screen looks like. You have the source column names and the destination column names, and you have information about what kind of privacy routines I'm using on the left-hand corner. You have an option of specifying propagate. That's what the first row indicates, PROP. It basically indicates that we are informing Optim that this particular column has to be propagated, and we are telling that we have to propagate this particular value to all the related child tables wherever this particular column occurs. The source column, I can use a variety of data privacy options, like I can use literals, I can use special registers, I can use expressions, I can use default values, I can even use user exits. That's shown in the 7th row. It says exit PGM name. PGM name is the name of the user exit which has been defined and is available in the Optim exit repository, and I can invoke it from the column map editor.